Hey, Tony Dubiel here, Cloud Architect. Today I'm going to walk you through a quick overview and demonstration of how Kubernetes and Cisco Contiv can work together to provide you with easy to use container deployment and orchestration, along with enforcing network policy to protect communication flows between various containers running on the platform. But before I do that, I wanted to point out that I'm starting a new blog site that you see here with the URL of betterblogcloud.weebly.com. I'm going to move over an archive of some of the older demonstrations and videos and blogs that I've done for similar topics, cloud-related topics, such as using Ansible as a configuration management tool to build OpenStack clouds, to configure OpenStack clouds. I did a little bit of work on the network programmability of using the Cisco Nexus Switch API and by leveraging Ansible to automate the provisioning of switches. I did some big data blogs and demonstrations of using Ansible to build Ambari Hadoop big data cluster on top of OpenStack. And again, today's focus is on Kubernetes. And having said that, I'm going to give you an overview of what you expect to find in this overview demonstration.
Okay, so what are we going to build in this lab of Kubernetes plus Cisco Contiv that provides network capabilities for VXLAN? It has options for layer 2 and layer 3 routing and BGP as well. So what we're going to do is we're going to look at Contiv. We're going to leverage a network that was built using VXLAN, but we're going to enforce a policy to restrict a particular protocol from connecting from a Redis slave to connecting to a Redis master. So in order to do that, what I've done is I've configured some of the lab to save time, and I used a MetaCloud OpenStack. So what I did is I built a project, and I built a private network in MetaCloud that I can use, and we're going to build VMs on these hypervisor nodes so that we can subsequently install and deploy Kubernetes on top of those VMs. So in order to do that, I had to select my configuration management tool of choice. In most of my blogs, I've leveraged Ansible. But in addition to Ansible, I could use heat templates. I could have used Cisco Cloud Center in some cases for a curated experience. I could use the Horizon dashboard, and so on and so forth. At the end of the day, all of these configuration tools point to the APIs that are exposed in the OpenStack control plane. So what we've done is we've built virtual machines. So we've installed Kubernetes. There's a Kubernetes master, which is the control plane of Kubernetes, and then there's Kubernetes nodes, which is the real estate that we can deploy our pods that we would use for workloads. So in Kubernetes, a pod is a wrapper around a container, and a pod receives a local IP address, but then it also, in order to leave the pod and to communicate between nodes, we need to have a network plugin, and that's where Contiv comes into play. And we have a VXLAN network that's already configured that we can use between these hypervisor nodes. That is a overlay configuration for the containers to use directly. So we've installed Contiv. Contiv is interesting because Contiv is actually deployed as a container. So it's a container that is lifecycle managed in the Kubernetes master node. And then it's also deploying net plugins that are also containers into each one of the nodes so that they can become an endpoint to connect the VXLAN and so on and so forth. And we'll be able to see the configured endpoints when we get into the lab. And then lastly, we're going to deploy pods. And our workload is a web server. It's a great web server that shows pictures of cats. And then we have a backend database, a Redis database. And that's where I decided to enforce a policy because we can restrict the traffic from a Redis slave to the Redis master, which is a TCP port 6379 that is used for replication between the database. So it's an easy place to enforce a policy. And then lastly, we're going to take a deeper look into how we set up the policies, the rule sets, which are similar to access control lists and routers, but how we enforce that into a Contiv network. We'll take a look under the hood of how we do that and how we can roll that configuration back as well. For purposes of a backdrop, I just wanted to show you the project that I built in Cisco MetaCloud OpenStack. And you can see that we have Kubernetes master and some Kubernetes nodes. This particular node is where we have set up a public IP address that we can expose in OpenStack as a floating IP, and we can actually connect to this IP address over the internet, and it will allow us to access that web page once we deploy the container in our lab. All right, let's see what we can see from our Kubernetes. This command allows us to see pods, services, deployments, and replication services. Now we do have some stuff built here, but we're going to build our new deployment, which consists of a web server that displays a bunch of different cat images. Everybody loves cats. And then a backend Redis master and slave. The reason why I chose that is that backend, the slave is always replicating and connecting on a particular TCP port to the master, so we can use that as a protocol or a port that we can manage through a policy in Contiv. So before we deploy our containers or our pods, let's go ahead and bootstrap some of the network. The first thing we need to do is to create our groups that we're going to label and tag to our pods. And in terms of the terminology that I'm using, things like or constructs like the pods, nodes, deployments, services, the replication services, all of those things I explain in much more detail on the blog posting. So if you click under Read More, there's very verbose description of a definition of each one of those terms and what they mean. But for purposes of this demonstration, I'm going to just explain it high level, and we'll try to go through this fairly quickly. So we have some EPG groups now that we can use. So before I deploy a pod, I'm going to show you a YAML file as an example. So we're going to take a look at the web server. And the web service or server is that particular container is deployed in a pod. The pod's the wrapper, and the web is similar to the Redis server. Each one, the master, the slave, and the web have their own YAML file. And what you can see is it's broken into two parts. We have the service, kind equals service. That's where we expose ports. So this container, the image was put together exposing port 5000 to the web server. And then what we're going to do is map that to port 30,080 that will expose to the internet from the MetaCloud network. Now, as we scroll down, we see the deployment. And in the deployment, something of interest here that's particularly important is that we are going to display a label. Sorry. Where are we at? Yeah, we're going to display a label that assigns the tenant, in this case the default tenant, but we could have created a new tenant in Contiv, the network name, default-net, and then that EPG that we just created, EPG-web, that will map the EPG to this particular deployment of web service pods. And then we do something similar with the Redis master. There's an EPG master and an EPG slave. And then that way, those become source and destination tags to create policies in Contiv that we'll take a look at in more detail later. So now that we have this put into place, we can go ahead and we can launch the actual YAML files. So the command that we use there is the kubectl create-f and then the file name of the YAML file. We go ahead and we've launched those, so now we can watch what happened, the result of that. We'll go back to kubectl get all, and we can see that we have 2 pods of web servers. The reason why we have 2 is because we had a configuration in the YAML file for a replication service of 2, or 2 replicas of the web servers for redundancy. Those services are load balanced to this service for the web. which is that that mapping of port 5000 to the pod, and then the exposing port 30,080 to the internet. And then we have the deployment of a Redis master, a Redis slave, and the web down here. And then we have the replication service configuration for the web and for the Redis slave and master. And we can see how many that they expect. So it's declarative configuration in Kubernetes, and we're saying we want one master, we want two slaves, and by 1 and 2, I mean 1 pod of master, 2 pods of slave. If 1 pod dies, then it would automatically spawn a new pod. And then for the web, we have 2. Okay, so since we've exposed the web server, I should be able to connect to it. So we'll go ahead and take a look at that. Let me bring up a Safari browser. Okay. So we're connecting to the web server. It's pulled down a group of images from a BuzzFeed and has stored them in a database, a Redis database that is replicating between a master and a slave. So as I refresh, we enjoy multiple pictures of cats. Everybody loves cats. So the web service is running. So now what I'd like to do is make sure that our Redis slave is connecting to our Redis master. So I'm going to do a kube-exec-it, and then I want to go to the Redis master. So I have to go up here to the pod, and that's the ID of that pod. We could describe that pod to go into low-level detail, but I just really need that part to connect to it through the console. So we're going to connect the shell. Okay, so now that I'm in it, I can do a net stat, and we should see connections from 2 of the slaves. And that's what we see here. This address is a part of the default network, the subnet, so it assigns IPs from that subnet. We should be able to ping them because I haven't restricted any connectivity. Oops. Right. Right, so we have network connectivity from the master to the slaves. Okay, so now that we've shown that without restricting anything we can connect, I'm going to show you how to move forward with configuring a group or a policy to map to the endpoint group of the Redis master. We're going to restrict the Redis slave that was assigned EPG slave. And then, that will give us an idea of how we can protect containers within the container space. Another thing I want to point out just real quick is on the networking side of things. Net CTL. These are Contiv command lines. Net inspect default net. This is another way that we can figure out what IP addresses were assigned. So this is the web container. This is the pod name. The pod is really just a wrapper for the container. So all these mechanisms that we're using to assign Contiv networking is based off of a plugin. So the CNI plugin, and then we can see how those mappings and those configurations are made from Kubernetes or from the command line of Contiv by inspecting the network. So this is the ID, the pod ID. We have endpoint group web assigned to default tenant. So that's what we configured from the YAML file. And then we can see that 20.1.9 is the IP address that was assigned to the web server. And then here's the Redis slave that we pinged earlier, the .11. And then we should have the master right here. So this was .10 for the master that we pinged .11. And then there's a slave that's on .12. 11, 7, 2, and 12. Sorry about that. Redis slave. So these are the same IDs that we see, that were assigned from Kubernetes in the pod. Another way that we can find out what IP addresses were assigned to our pods is actually from Kubernetes. So kubectl get pod -o wide will show us IPs. So again, we can see master.10, slave 12 and 11, and then the web has a .9 and a .8 because there's two web servers, and there's additional IP addresses for other constructs of Kubernetes that are a part of a different namespace. So this was the default namespace and default tenant, but some of the controller resources from the Kubernetes master are actually a part of kube system namespace. So namespace is really a Kubernetes construct used for multiple users, multiple tenants. So you kind of have the space of the controller and then the space of users. We're on default, but we could have created a new namespace and created a new tenant in Contiv. But for purposes of simplifying the demo, I just left it on the defaults. So let me show you what we could do to see everything. We could do -n for namespace and kube system. We could also do all namespaces, but I just want to show you these ones here are a bunch of different pods that are for the control plane and the plugins for Contiv. They're all deployed, as pods. We also have Prometheus, which is a management tool that I'll probably show you in a separate blog because it has a ton of details in that of itself. And then we can see a bunch of different services in Kubernetes like DNS and the API server and so on and so forth. So I just wanted to point that out, and also the networks that are used. These are the actual private IP addresses of the master and node that were assigned these IP addresses from OpenStack for the virtual machine. So these containers are deployed on the master node into the virtual machine using that private IP space. And then the 20.1.1 network is based off of Contiv networking. So that was that network that we named it default net. So some of the services are actually on that network because they're extended to the worker nodes, and then some of them only exist on the Kubernetes master. Again, there's much more detail explaining these services and the mechanics of Kubernetes on the pod if you click on read more. But I just wanted to give you a real high-level overview. Another thing that I wanted to show you is, in addition to the command line of Kubernetes and Contiv, there's also a GUI. So from the user interface, we can see everything that we looked at. So these are a view of pods. So we could also look at if we had multiple namespaces, we can change namespaces. So kube system. These are all the Contiv and Kubernetes master services. I can go back to defaults and we can see what we've been building, and we can look at it from the replication sets. We can look at it from services, and so on and so forth. So everything that we were viewing from the command line, we could have just used a GUI if we wanted to. So we're going to go back to the command line and configure the Contiv policies, and then take a look at the impact to the container space, from the pod point of view of the traffic policy that we enforce. All right, let's go ahead and complete our policy configuration in Contiv. We've already put together our endpoint groups for EPG for web, the Redis master, and the Redis slave. So now what we need to do is create the actual policy and the rule sets, or the rule set to deny of the port, and then we can demonstrate that it works. So let me go ahead and start here by creating a policy called Redis, because Redis is the database. Go ahead and do that. And then we're going to create a rule. We're going to deny TCP port 6379. So we do that by netctl policy rule add -t for tenant, it's default tenant, -d for direction, inbound, so inbound towards the Redis master. Protocol TCP port 6379 coming from the group endpoint slave, and there's a sequence number of 1. And that's important if we're going to add multiple rules. Then we need the sequence number so we can add or delete or change a particular rule set. We have to call that specific sequence number. Very similar to like an access control list in a router. Okay, so we've created that rule, and then the next thing that we need to do is we've got to connect the policy. Well, actually, let's go ahead and take a look at our rule set just to make sure that we did that right. So this is a rule dash list. So we can see that we've created this rule in a direction, coming from EPG slave, and it's going towards the EPG master. That's where we're going to apply this rule. We're going to block 6379, and that's the port that it uses to replicate, so that slave is always trying to connect to the master on that port. Right. So now that we have that, we can map the two together. So this is really analogous to assigning an access list to an interface as an example. So this is what we're doing is we're going to take that policy with the rule set that we just created, in the default tenant, default network, and apply it to EPG master. And we use that label when we created the Redis master, so that way it will apply, it'll apply this policy and this rule from this command. Okay, so now that we have that put into place, we can take a look at the impact that that does on the master, because we can look at netstat to see those connections. So earlier we saw that we had a connection from both of the slaves using that port, TCP port 6379, and that was established. So we should see that break and not be able to connect. So we need our cube CTL to figure out the master's ID so we can connect to it. Right here. And we're going to do a cube CTL exec -IT to the pod, and then we need a shell for the console connection. So now we're connected, to the Redis master, and I can take a look at the connection. And what we can see is that the connections have been knocked down. So to see the impact again of that rule, get out of there, and what we're going to do is we're going to remove that rule. So by removing the rule, I need to use that sequence number, which is 1. If we had multiple entries, then we would go to a specific rule set. And this is what it looks like. So we're going to remove that rule from this policy. Okay, so now it's gone. We up arrow key back to our exec command, and then we can see that we should have those connections come back. And there they are. We've got one from both of the slaves connecting on 6379 as they normally would. So all we did was block a port, but it's very important because in OpenStack, I can block the ingress and egress connections to the virtual machines where we're hosting Kubernetes cluster on top of. But I'm unable from OpenStack to control the communications that are going between the containers. So I can manage security groups for traffic between virtual machines, but in the container space, it's really without something like this to be able to enforce policies, which is the case for most of the CNI plugins, with the exception of Contiv, where Contiv gives us the ability to locally block or allow for traffic. In addition to these types of policies, there's also network policies where we can throttle bandwidth. So we don't have time really to configure that, but I have configured that separately. And what you can do is you can enforce a bandwidth policy to to police how much bandwidth a particular container can consume, where that gives you the ability to throttle back some of the chatty types of traffic that may impact other pods that are running on that same node Kubernetes node, which could be on a virtual machine or on a bare metal server. It gives you the ability to police that as well. So okay, so I guess we'll probably continue on with some more Kubernetes blogs and demonstrations in the future. Maybe look at those bandwidth policies or something in that regard, or how to deploy Kubernetes with Ansible. Might be a good one, like KubeSpray uses Ansible to install Kubernetes. So there's a lot of different topics that I'll take in consideration, and I hope that you join the next blog video and read up on the blog too. A lot more details on how Kubernetes and Contiv works in the documentation. Thanks and take care.